Hi students, now we are going to explain the terms thrust and pressure. Before that, I will take one simple example of a drawing board pen, either this flat type or of this type. Okay, you can see that there is a sharp pin at the bottom and there is a flat surface on its top. So how do we fix this pin on the board? So we will keep it like this and we will press it. We will press it, isn't it, with our thumb. While pressing the pin, do you exert some force on it? Yes, sir. You have to apply some force on it. So how is this force acting on the top surface of the pin? This force acting on it will be perpendicular to its surface like this. Okay, so the force acting on the pin will be perpendicular to the surface. So if you represent this is the surface on which the force is acting perpendicular means so this is the surface. Such force which is acting perpendicular to the surface only is called as thrust. Understand? So what is meant by thrust means the perpendicular force acting on a surface. So this is called as thrust. So thrust is nothing but a force only. So what should be the unit for thrust? The unit for thrust is Newton only. The unit for thrust is Newton. Capital N is the symbol for Newton. Understand? Okay, now what is meant by pressure? We are going to see what is meant by pressure. Now, if you divide the force acting on the surface by the surface area pi r square of the circular pin. So, how will you find the surface area of the top surface? It is circular in shape. It is equal to pi r square. So, if you divide the thrust or the force, perpendicular force acting on the body by its own area, this ratio of force per unit area, which is also called as thrust per unit area. Thrust per unit area or the perpendicular force acting per unit area, this ratio only is called as the pressure. So the symbol for pressure is P. And P is equal to F by A is the numerical expression. So, force is in Newton and area is in meter square. Therefore, the SI unit of pressure, is Newton per meter square. Newton divided by meter square. So, how to read this is Newton per square meter or Newton per meter square. So you can also write Newton per meter square like this also. Now as an honor for the scientist Pascal, another unit for pressure. So 1 Newton per meter square also is equal to 1 Pascal. So Pascal is also another unit for what? The pressure. And the symbol for Pascal is PA. Okay. So there are two units for pressure. One is Newton per meter square. The other one is Pascal. Okay. Now let us take a very simple example. Suppose we go to the beach and we just play with the waves. Okay. Water. The waves produced by the sea water. And suppose if you stand near the close to the beach, what will happen? Sometimes the waves will pass your feet and it will go back. At that time your feet will automatically go inside the sand. Have you observed that? Yes, it is because of the body weight. The total body weight is acting below our feet. That is called as pressure. The weight of the person divided by the feet area is called as the pressure exerted by the person on the sand. And after 2-3 waves will just pass you, the more deeper your feet will go inside. This is because of what? The thrust per unit area. Because when we stand on the ground, okay, our entire weight of the body is nothing but gravitational force that is acting perpendicular to the surface of the ground. So it is called as thrust. And where this thrust is acting, suppose if a person is standing, I will take this is a person standing like this on the ground. The total weight is concentrated only in this small area below the feet. Suppose if the same person is lying down, okay, same person is lying down like this, the same weight, body weight is the same whether he stands or lies down. Now this entire weight of the body is acting on a larger surface, so more deep inside the sand we cannot go. When a wave will pass you several times also, very small depth only you will penetrate inside the sand. So in both the cases, the person is the same, his weight is the same, but the area over which the weight acting is different. So lesser the area, greater will be the pressure. Greater the area, lesser will be the pressure, because the area is in the denominator. Understood? So these are some of the examples. One more example is, we are all having school bags, shoulder bags, isn't it? So you can see here the shoulder bags, school bags, sky bags are all provided with the straps. So when you carry this bag, it exerts because of the books, weight of the books and notebooks behind, it will be stretched backward. And if it is very sharp and thin rope, means it will cut your shoulders. It will be painful. So to avoid that, only flat and wide straps are being provided, so that the force exerted acts over a larger surface area, so that the pressure will be minimized. Understand? Suppose if it is a small rope, thin rope, means what should have happened? You see, the same book weight will pull the bag in the backward direction, and below that small rope, the surface area will be very small. So force per unit area, the pressure will be larger. Understand? Okay, have you ever observed the tires of some trucks and all, heavy trucks which are going in the desert areas and all, heavy trucks moving in the desert areas and all, the tires, if you observe, it will be very broad. Understand? So that it can easily move over the soil, sand. Suppose if the tire is very thin, okay, narrow, what will happen? It will deeply penetrate into the sand and it cannot come out. So this is the idea, okay, thrust and pressure will be applied in so many things which we use in our everyday life. So what is the thrust? How did we define thrust? Any perpendicular force, that is also called as normal force, acting on a surface is called as thrust. It is one type of perpendicular force. So its unit is in Newton only, okay. And this thrust acting per unit area, thrust divided by area, that is only called as what? Pressure. I hope you must have understood well. Fine.